refrigeration system. Okay. Now, majorly on this unit, there will be one theory question and one numerical. Right? Now, in first unit, there are two parts: air refrigeration system and refrigerants. Right? First unit is little vast, but now in this unit, how will be the question paper pattern? Maybe the question one. Generally, question 1A is theory, 5 marks, and B is numerical, 10 marks. But sometimes they may ask A and B both theory, right? Okay. Now, merits and demerits of air refrigeration system. Okay, already we have seen. Now, studying this by yourself will not be having any issue. Okay, because it is a revision, it is not teaching. Okay. Now, methods of air refrigeration system is simple air cooling system. Now there one more thing is there, simple air evaporative. Wherever now as per syllabus this is not there, but as an additional information I will tell you what is that evaporative cooling system. Evaporative cooling system is nothing but just one additional heat exchanger. In that we are providing the water evaporative cooling. In heat exchanger only further extension of that cooling is there, right? As per syllabus guideline, they may not ask it, right? But in case if they will ask, no need to get confused. It is not a different thing. Okay? So as per syllabus, simple air cooling system, bootstrap air cooling system, reduced ambient air cooling system, regenerative air cooling system. Okay? Now first, simple air cooling system. Now, if theoretical question will be asked on this, it will be for 5 marks. Okay? In that 5 marks, what is expected? Schematic diagram, TS diagram, and formula. And little bit elaboration about the processes. Only these things are expected. Right? Till now, they have not asked more than 6 marks question on this theoretical question. Right? Now, first, simple air cooling system. Okay, schematic diagram. All of you refer the diagram from PDF only. You might have seen the diagrams from other tech max or technical knowledge. They are little confusing. आप लोगों ने realize किया है diagrams are little confusing. Okay. Now see here, ambient air we are taking in. Then we are first ramming of the air. Then it goes to the main compressor. Some of the air is bled up from main compressor sent to the heat exchanger. Now in heat exchanger, rammed air is cooled. Sorry, this compressed air is cooled by using the rammed air. Okay, and then it's sent to the turbine. Before cabin, it is sent to the turbine. In turbine, it is expanded isentropically, and then it is sent to the cabin. Okay. Yes. Now first ramming process. Right here, this is the diagram, TS diagram. What are all these red lines? Constant pressure lines. Okay, this is the ambient pressure, cabin pressure, actual ram pressure, ideal ram pressure, and main compressor pressure. Right? In that, 1 to 2 is what? Isentropic ramming. 1 to 2 dash is actual ramming. If ramming efficiency is given, then you need to consider this. I have sent you the previous numerical, solved numericals today. In that first numerical you might have seen, if ramming efficiency is given, then you need to consider this. Okay? If the ramming efficiency is given, then in that case, what will be at the numerical? Numerical will be actual ramming divided by ideal ramming. Because efficiency is always less than 1. So numerator will be less, denominator will be more. Likewise you remember. Okay? Then 2 to 3 isentropic compression, 3 dash actual compression. Agar in numerical also, if efficiency is not given, directly consider isentropic as a actual. In case efficiency is given, you need to calculate actual values, and to calculate the power and to calculate the refrigeration load, you need to consider actual values, not isentropic values. Right? Power काढताना आणि रेफ्रिजरेशन लोड काढताना ॲक्च्युअल व्हॅल्यूज द्यायचे, आयसेंट्रॉपिक नाही. ठीक आहे. दिस इज युअर TS डायग्राम. ओके. Now this derivation we have already seen. Okay. Now in this formula sometimes may be required. What is that? T2 by T1, output temperature of ramming air divided by ambient temperature is equal to 1 plus gamma minus 1 divided by 2 into m square. M is Mach number. To calculate T2, जो मैंने कल आज जो मैंने PDF भेजी है उसमें ये फॉर्मूला यूज किया है एक न्यूमेरिकल, ठीक है. Now you may get confused. P2 by P1 is equal to T2 by T1 raised to gamma divided by gamma minus 1. What is this? This is the pressure temperature relationship for isentropic process. What is this? Pressure temperature relationship for isentropic process. Now generally in numerical what we need to calculate? Temperature. Pressure is given. Sometimes it may be possible that temperature is given, pressure need to be calculated, right? So remember this P2 by P1 raised to gamma divided by gamma minus 1. If it is like P2 by T1 is equal to P2 by P1 raised to gamma minus 1 divided by gamma, right? This ramming efficiency is your actual rise in pressure divided by isentropic rise in pressure, right? This formula could be in terms of pressure, could be in terms of temperature, right? Just remember diagram. From diagram, always remember efficiency is less than 1. And if it is less than 1, numerator has to be less than that of denominator. Okay? Then this compression work, MCP delta T, okay? During compression process, refrigeration, MC delta T. For work or for heat, fundamental formula is what? MC delta T. If Cp is not given, it is 1. If it is 1, don't consider. If it is given 1.005, take it. Otherwise, if it is not given, don't take it. Generally they are giving, okay? And it will not make much difference, right? Refrigerating effect is MACP into temperature difference during the refrigeration process, right? From this formula only we are calculating the mass. Mass is equal to refrigerating effect divided by Cp into T6 minus T5 dash. Refrigerating effect is what? 210 Q. 210 Q. To get the value in kg per minute. Right? Here, divided by 60. See here, lot of formulas are there. What are the formulas that you need to write?
Pressure temperature.
No. Pressure temperature relation, not everything, just first pressure temperature relationship, then MA, this formula, MA, 210 divided by this, power and refrigerating effect, or COP. Only these formulas are necessary, okay? Schematic diagram, TS diagram, little bit elaboration about processes and these formulas, okay? In exam, be conscious about for each mark you have 2 minutes. If question is asked for 5 minutes, you need to complete it within 10 minutes. Accordingly, you have to plan, right? Yes. Look at this numerical just by looking at. See here, 1 to 2. In case of now this here they have not given the efficiency. So isentropic is considered as ideal. 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. Right? So straightforward, you will get this T2 by T1 is equal to P2 by P1 raised to gamma minus 1 by gamma. From goes on calculating the temperature. Okay? Here. Yes. Here is the one twist here that you need to remember. Okay? Related to the temperature reduced in the heat exchanger. What they have said? The temperature of the air is reduced by 50. Okay, here straight away they have given 50 degrees centigrade. Okay, in case if they will tell that in heat exchanger 50% enthalpy is reduced, so output temperature will be 0.5 that of input temperature, And for this calculation, you need to take the temperature in degree centigrade, then convert it to Kelvin, and everywhere else take the temperature in degree Kelvin. Only at this location you need to take the temperature in degree centigrade. Where? In the heat exchanger, only when output temperature relationship is given in terms of 50% enthalpy or 30% enthalpy. If suppose 70% enthalpy is reduced in a heat exchanger, so what will be the output temperature of heat exchanger?
0.7.
0.7 or 0.3? 0.3. 70% एंथॅल्पी कमी होते म्हणजे टेम्परेचर जास्त कमी होते. 70% म्हणजे 1 मायनस 0.7 म्हणजे 0.3. राईट. तिथं मिस्टेक होण्याची शक्यता आहे. फक्त मी या ठिकाणी तुम्हाला ट्विस्ट सांगणार आहे की ज्या ठिकाणी तुम्ही कन्फ्यूज होऊ शकाल. ठीक आहे. स्ट्रेट फॉरवर्ड दिस calculating temperature, calculating mass straight away. If CP is not given, take it 1, power in kilowatt and COP. And always remember, COP of air refrigeration system is less than 1. It is generally around 0.2, 0.3, 0.4, 0.5 or max to max 0.6. जर तुमचा COP रेंजपेक्षा बाहेर येत असेल तर कुठेतरी कॅल्क्युलेशन मध्ये मिस्टेक झाली असं ओळखायचं. ती मिस्टेक सापडते का बघायचं. सापडत नसेल तर टाइम वेस्ट करायचा नाही. ठीक आहे. सेकंड प्रॉब्लेम. ओके. Here, this compressed air cooled in a heat exchanger to 67 degrees centigrade. Here, here take the catch. Okay, 267 degrees centigrade means T4 is 67 degrees centigrade. Sometimes they may say that reduced by 20 degrees centigrade. In that case, what you need to take? Input T3 minus T4 is equal to 20, right? By and 2, that difference you remember. Okay. Here 1 to 2 is isentropic ramming. उसमें actual ramming और isentropic नहीं है, only isentropic is there. 2 to 3 is there, actual as well as this. Whenever actual is there, efficiency is given. Okay. Remember the efficiency formula. Now, why I have said remember the diagram? Because here, look at this line 2 to 3 and 2 to 3 dash. Which line is longer? 2 to 3 dash. Means it should be at the denominator. Right? Now 2 to 3 dash is what? Actual. Right? Why actual is more? Because in isentropic we are considering friction is 0. But there is no system that it has the 0 friction. Always there is some friction, right? So that's why temperature is increasing. Now here, look at this 4 to 5 and 4 to 5 dash. Which is longer? 4 to 5 is longer, right? This line is going up. Don't look at the length of line. Just look at the position of point. It is not... let me take my words back. It is not about length. It is the position of point. Which point is at upper side, right? Here 3 dash is on the upper side. As it is the inclined line, its length here. As it is inclined line, its length may be more, right? So in that case, length is not the only parameter to judge, right? So here P is less temperature. Now here, what is our expectation? In isentropic turbine to reduce the temperature, but whatever the drop we are expecting, that drop we are not getting. Why? Because of friction again. So here what will be the case? At the numerator there will be actual drop in temperature divided by isentropic drop in temperature. Here isentropic rise in temperature divided by actual rise in temperature. Okay. So same things are there. efficiency, calculate temperature, isentropic temperature, then actual temperature. Okay, then again isentropic temperature, actual temperature in the turbine. After this mass, and after this COP. Very simple, right? Here also similar problem is there. Okay, first calculate this. Here little extra twist to this formula is used here. जो initial derivation में था ना, that formula they have used here. Okay, how means actually here now ramming process. From ambient to ramming, why pressure is increased? Because kinetic aeroplane is running at high speed, so that kinetic energy of air is converted into the pressure energy. That's why there is a rise in temperature. Okay, so that rise in temperature here they have calculated T1 plus kinetic energy. Kinetic energy is nothing but half mv square. So we are taking per unit mass. That's why v square divided by 2060. Okay, that's the only difference. Rest is same. Okay, right? Now, as there are simple air cooling system, similar things are there. In bootstrap air cooling system, we are using the 2 heat exchangers and 2 compressors. Okay. Now process in short. First, air is compressed in the main compressor, sent to the first heat exchanger, temperature reduced, again sent to the second compressor. Then temperature reduced in second heat exchanger, then sent to the cooling turbine, and then to the cabin of the air. Secondary compressor is run by the cooling turbine, and primary compressor is run by the gas turbine. Right? I think similar working you might have studied in the turbo machinery. Turbo machinery मध्ये तुम्ही study केलं असेल. ठीक आहे? Now processes are there. 1 to 2 ramming, to here TS diagram. 1 to 2 ramming, 2 to 3 isentropic compression, actual, all these. Okay. Now here 2 compressors are there, right? But while calculating the power consumed by the compressor, we need to calculate power consumed by main compressor only, not secondary compressor. Why? Because secondary compressor is run by turbine only. So there is no separate power we are providing for this, right? Similar things are here, right? All these are the constant pressure lines. Okay, these formulas. This one numerical is there on the bootstrap. Here they have mentioned the first heat exchanger and the enthalpy of air. Here enthalpy is reduced by 30%.
याच्यात डोळे याच्यात पाहू राहिलो
Right?
अजून जास्त
Now
डोळे
in that case, look at
पाणी
this.
आहे
First we are calculating temperature after ramming, then temperature after the compression, okay, then isentropic temperature, actual temperature. Now temperature after heat exchanger. What they have said, in first heat exchanger 50% enthalpy is reduced. Now what is enthalpy? Enthalpy is nothing but Cp into temperature. Means enthalpy is directly proportional to temperature. As 50% enthalpy is reduced, 50% temperature is reduced, right? So output temperature of heat exchanger is equal to 0.5 into input temperature of heat exchanger. Why 0.5? 1 minus 50% means 1 minus 0.5. That's why 0.5, right? In case 30%, 1 minus 0.3. In case 70%, 1 minus 0.7. Okay? And for this conversion, you need to take this temperature in degree centigrade. Why? It will take in degree Kelvin. That temperature will be too low. Even though you will convert it later on, that will not match, right? So only this point remember. In heat exchanger, that is only when enthalpy reduced case is given. Okay? Effectiveness च्या केस मध्ये ते करायचं नाही. इफेक्टिव्हनेस चा फॉर्म्युला मी एक एक्झाम्पल सॉल्व करून दिलेला आहे. इफेक्टिव्हनेस साठी फॉर्म्युला तो बघा एकदा. आपण जो सुरुवातीला इफेक्टिव्हनेसचं सांगितलं होतं ना, दॅट इज नॉट करेक्ट. ओके, इफेक्टिव्हनेसचा नवीन फॉर्म्युला मी आज सेंड केलेला आहे तुम्हाला. तो एकदा व्यवस्थित बघून घ्या. ठीक आहे. Then remaining things same, second efficiency, temperature, okay. Then calculating power and all those things, okay. Reduced ambient. Now this reduced ambient is used for very high speed aeroplane, right? Now here what we are doing, here look at this ram air, whatever the ram air is there, that air we are first expanding in the turbine, right? So whatever the air that we are using, that air itself, its temperature we are reducing. That's why reduce the ambient. Means whatever the air that we are using for the cooling purpose in the heat exchanger, its pressure is less than the ambient pressure, right? So we will get the temperature drop in heat exchanger itself, and after this again we will get this, okay? This air system and all those things are used here, okay? Now here TS diagram will be same, right? Only cooling methodology is changed. So TS diagram will be same. TS diagram is about the compressed air that we are sending to the cabin, right? And here they have only changed the cooling methodology. Only schematic diagram will be different. TS diagram will be same, right? This is the COP formula here. Regenerative air cooling system. Now in this regenerative air cooling system, whatever the air we are sending to the cabin, some of the air we are bleeding off. थोडीशी air घेतो इथं in the second heat exchanger. In first heat exchanger, ram air only we are supplying. Okay? This will be same. TS diagram will be same, right? Only in case of bootstrap we are using the two compressors. In remaining in bootstrap we are using two compressors, two heat exchangers. In remaining all cases we are using single compressor, but heat exchangers may be two, right? Here also we are using the two heat exchangers, 3' to 4 and 4 to 5. Okay? Remaining things will be similar, right? Now last point from air refrigeration system is this. Comparison of various air cooling system used for aircraft, right? Now here they may say only about the dry air rated temperature, okay? Now in that case you need to, this graph is very important, okay? On the ordinate there is a dry air rated temperature, and on the abscissa there is a Mach number. Mach number varies from 0.2 to 2.6, and here -60 to 40. No need to show all these cycles. Only simple system. Look at simple system. Minimum temperature is around -20. And look at the graph of simple system. As Mach number increases, temperature increases too much. Now for the cabin, we require temperature at least -10, -20. But as Mach number increases above 1 or above 1.2, what is the dry air rated temperature? 10. At 1.4, it is about 20. So from this graph, we can conclude that for the simple system is not suitable for the high velocity aeroplane, right? Now next, look at this regenerative graph and bootstrap system graph, right? These are suitable for moderate speed of aeroplane, right? Afterwards also its temperature goes on increasing. And fourth is the reduced ambient system. हे चारच ग्राफ काढायचे, बाकीचे ग्राफ काढायची गरज नाही. ठीक आहे, फक्त 4 ग्राफ काढायचे. फॉर्म्युला लिहायचा आहे ड्राय एअर रेटेड टेम्परेचरचा, ओके. अँड हिअर you need to write only reduced ambient system is the system where its temperature reduces with increase in Mach number. Initially, dry air rated temperature reduces with increase in Mach number. Later on it increases, okay. So this system is suitable for hypersonic aeroplane or hypersonic missiles, right? This is the air refrigeration system.